By how much does the weighing scales underread the mass of a person at the equator? So we've got the Earth here that's spinning around. Maybe there are some scales here. The person standing on the scales. Gravity's acting down on the person. Scales will need to supply a little bit less than the person's weight, because the sum of those two forces will end up being the centripetal force. Remember, we just need a single force acting inwards, or a net force. So the difference is just going to be the centripetal force. The under reading is the difference. So that's all I have to work out. That's 90 times the angular velocity of the Earth. Now, the angular velocity of the Earth is 2 pi. It's 1 revolution in 24 hours, which is 2 pi, and I've got to get that in radians per second. So that's my angular velocity. If I work that out, 2 pi divided by 24 divided by 3,600, that's 7.27 times 10 to the minus 5 radians per second. So I do 7.27 times 10 to the minus 5, and I times that by the radius of the Earth. I've got to square it as well. Getting a bit messy there. Okay, so 10 to the minus 5 squared, and I've got to times that by 6,400 kilometers. And that should give me that sort of difference that we would observe in the person's weight. So that's 90 times omega squared times radius of the Earth, and we get 3 newtons, 3.05 newtons, which is about 300 grams.